the pH scale. In this section, we're going to learn how to calculate pH. Now, the pH of a solution is used to indicate the acidity of a solution. It has values that usually range from 0 to 14. It is acidic when the values are less than 7, like from 0 to 7, or actually if it's a very strong acid solution, it can be just a tiny bit less than 0, like maybe negative 0.1 or negative 0.5. Now then, it's neutral at the value of 7, and it is a base when it's greater than 7, from 7.1 up to about 14. Now, if it's a really strong base, it could be slightly more than 14, maybe like 14.1 or something like that. So, our acidic solution, the pH is less than 7. The hydronium ion concentration is greater than 1 times 10 to the negative 7. Neutral, pH is 7. Hydronium ion concentration is 1 times 10 to the negative 7. If it's a base, then the pH is greater than 7, and our hydronium ion concentration is less than 1 times 10 to the minus 7. You go, what? Well, remember, hydronium ion concentration refers to an acid. So then remember, you always think of this as acid, then that makes sense. The pH of a solution is commonly measured using a pH paper or a pH meter, and it can even be used using, red cabbage indicator. And look at these different colors that will tell you the different pH levels, whether it's something mechanical or something so simple as making a cabbage indicator, if you didn't have pH papers there. Now on the pH scale, values below 7 are acidic, like we mentioned, and the value of 7 is neutral, and values above 7.0 are basic. So up here near close to 0, you'll see our 1 molar hydrochloric acid solution, and between 1 and 2 we have our lemon juice, and vinegar is between 2 and 3, etc. And then down here below, well, I should say, between 7 and 14, we are going to have different bases, okay, like soaps are examples of bases, ammonia, milk of magnesia, your antacid. Think of that. I wonder why they called it an antacid if it's going to neutralize the stomach acid. All right, so let's classify and identify each of the solutions as acidic, basic, or neutral. Press pause and come on back. Okay, well, pH of 1.5, of course that's an acid because it's less than 7. The hydronium ion concentration, so that means the acid concentration, look at this. This is smaller. This negative 8 is smaller than negative 7, so that means it's a base. This pH is 3, that means it's an acid solution. pH is 7, that's neutral. The OH concentration is 3 times 10 to the negative 10. Well, in order to calculate that, we would say that, okay, remember when we think of the OH, we think of a base. So base, if that's less than negative 7, well then that means your base is not very much, so that's going to mean it's acidic. Okay, our hydronium ion concentration, is negative 12, which means it is less than negative 7. So that means that it doesn't have a whole lot, and that is a basic solution. The pH scale is a logarithmic scale that corresponds to the hydronium ion concentration of aqueous solution. It's the negative logarithm, base 10, of the hydronium ion concentration. pH equals negative log hydronium ion concentration. Now, I realize that most of you have not done logs in your math classes to this, unless you've taken higher level math. Okay, so when we're doing these problems, if you cannot use and cannot find your LOG button, or if your calculator is a little bit different than others and you need help, please make sure that you end up sending me a message so I can help walk you through this. Don't spend more than 10 minutes trying to figure it out on your calculator if you can't do it kind of immediately. It's not worth a try. Every calculator is different, so we got to work on it together. All right. Now, if the hydronium ion concentration is 1 times 10 to the negative 2, well, because it's a base 10, we can go the negative 2, which is a positive 2. The pH is a positive 2. And you go, what? Well, don't worry about that. We just want to have you learn how to use your calculator. We'll just plug that in. We'll show you how to plug that in. I meant to say that if you have, when we're two significant figures of your hydronium ion concentration, that when you're trying to figure out how far do you carry out the value on your pH, well, you have your first number, which represents the power, then the two numbers after the decimal, okay, or however many numbers. If you have two significant figures here, that means you're going to have two numbers after this decimal. Okay, so because pH is a log scale, the change of one pH unit corresponds to a tenfold change in hydronium ion concentration. So if a pH is of 2, the hydronium ion concentration is 1 times 10 to the minus 2. A pH of 3, it is 10 times less acidic. The pH of 3 is 10 times less acidic. And so 1 times 10 to the minus 3 molar. A pH of 4 is going to be 1 times 10 to the minus 4. So let's think about it another way. If I had something a pH of 4 as opposed to something a pH of 2, you might go, oh, well, it's just, 2 different. Heck no. And you might go, oh, well, this is a 10 and this is a 10. It must just be 20 times different. Heck no. Because it is a power of 10 for each one, 10 times 10, differences in pH value. So the difference in pH value between 4 and 2 is 10 times 10, i.e. 100 times. So the pH of 2 is 100 times more acidic than the pH of 4. So little changes in blood pH actually make a big deal. So when you're going, oh, well, that little change in pH doesn't matter for our water or for our blood, you're so wrong because you forgot how much difference each little bit matters. All right, so here we go. Let's start using our calculator. Pull it out, make sure you can do this. So if a solution of aspirin has the hydronium ion concentration of 1.7 times 10 to the minus 3, what is the pH? Okay, so we need to analyze the problem. We're given this. We need pH. We're going to connect with a pH equation. So our pH equation that you need to write down and remember is pH equals negative log hydronium ion concentration. So as we plug in the hydronium ion concentration in this problem, we have the negative log 1.7 times 10 to the negative 3. Now, the question is how do you plug that in your calculator? Well, it depends on your calculator, so try what they say here. If your calculator is like a really nice one like the TI-82, 83, 84, you can go straight. You can go negative, that's not a minus, that's a subtract. That's your plus negative button. You could press your plus and negative, then press log, and then press 1.7, don't press times 10. Use your EE, or however you plug in your exponent there. Plug that in, and when you do, you should get the correct answer. And so some people you can go straight and use this. Other people kind of have to do this problem backwards depending on the calculator. They'll plug in the 1.7, and then however you get your EE or EXP button, you press that. Then you're going to press your log. Then you press your plus negative button. And when you do, which that explains here, all in one step, you get this long number. Or maybe you don't get this long number, but that's okay because you only need two significant figures here, so you're going to only need two numbers after the decimal. So here's two numbers. We look here. Yes, we're going to need to round up. So your answer is 2.77 for the pH, which makes sense since our aspirin is a little bit of an acidic solution. Then, of course, this is going to be an acid because it's less than 7. All right? Find the pH of a solution with the hydronium ion concentration of 4.0 times 10 to the negative 5. Press pause and see if you can do it. Now then, when you get through doing it, and you get about this far, and again, if you can't do this on your calculator, and you've tried a couple of different ways, please don't spend more than 10 minutes trying to figure this out. Feel free to Google it. Should answer your question, but also then feel free to message me or text me so I can help walk you through it depending on your calculator. So don't think it's you, okay? It's not you. It's every calculator is a little bit different, so we need to work on figuring it out. So when your calculator gets you some long number, we got to look back up here. Oh, there's two significant figures here, so that means we have to go two numbers here, but we have to go to the next one to look to see, do I need to round up? Yep, so that's going to be 0.40. So it's going to be 4.40. All right, one more learning check. press pause and see if you can do that. Here we go. Did you get 3.54? Hopefully you did. Now that you know how to do that, let's go backwards. What if they give us the pH and ask for the hydronium ion concentration? So, given the pH of a solution, we can reverse the calculation to solve for the hydronium ion. We will do the opposite of this formula. Well, the opposite of log, though, is not just divide through. You cannot divide through by log. The opposite of log is your second button, your second on your calculator or your shift key. In the olden days, a billion years ago, in my learning, they would call it the anti-log. However, if you call it the anti-log, the math people are going to laugh at you and go, "Oh, you must be taking chemistry," because that's an old chemistry term. So feel free to not call it the anti-log. Feel free to call it the second log. All right. So we're going to reverse this. We're going to do the opposite of this formula to solve for the hydronium ion concentration. And the opposite is second log negative whatever the pH value is. Okay, now, if you can't do this on our next problem with a couple of different tries, because remember all the calculators are different, you may have to plug in this number first, then go second log. You may have to go inside and outside and backwards and frontwards, or you may be able to go straight through if you have the higher level calculator. So determine the hydronium ion concentration for a solution having the following pH value, 3.42. All right, so here we go. We state the given and needed quantities. We're given the pH, and we need a hydronium ion concentration. And so we're going to plug in for our formula. We're going to go the hydronium ion concentration equals the second log, which is your inverse log or second 10x, then negative the value. Okay, so when we do that, we have pH equals the pH value of 3.42 has two digits on the right, which means we need two significant digits, so we're going to have an overall two significant digits in our hydronium ion concentration. So 3.8 times 10 to the minus 4. When you get done, let me come back here, and when you do that, you'll see this on your calculator, and so then to get it to the right amount of significant digits, we're here. Okay, last but not least, the pH of human blood is about 7.4. What is the hydronium ion concentration? Okay, so to solve for this, when you're given the pH, you know we're going to do the backwards way. So press pause and see if you can solve this. All right, so did you get 4.0 times 10 to the minus 8? Hopefully you did. If not, message me and let me help you do this together.